In this video, we will learn about instantaneous velocity and speed. The concept of instantaneous velocity and speed is different from what we have studied in our last video, that is average speed and average velocity. So let's see the difference. Suppose we know the nature how the object is moving with respect to time. So this is my time axis in seconds and this is my distance axis in meters. And you know the nature of curve, how it is moving with respect to time. Suppose this is the nature and you know this relationship, how distance is a function of time. It can be any function. Now in the concept of average velocity and average speed, what we were doing, we were seeing if we wanted to find the average velocity or average speed between these two time intervals. First interval is this one. Suppose this is t1 and this is suppose t2. So what we were doing, we were looking how much distance the body has covered when it is moving from this point to this point. In the case of average speed, this distance divided by the time interval, this time interval give the average speed. But in the case of average velocity, we have looked, we calculate the how much distance, this distance, suppose this is x2 and this is x1. So we find the net displacement between these 2 points. This 2 point, that is x2 minus x1 and divided by the time interval, that is t2 minus t1, and we say that is our average velocity. So these two concepts of average speed and average velocity we have already covered in our last videos. So in this video we are interested in finding the instantaneous velocity. So how it is different from the past concept? We will look here. Now suppose if one person is interested in finding the velocity and speed at particular point at this time interval, suppose this is t1, or the person is interested in finding this instantaneous velocity. We will talk about instantaneous speed in the later section of this video, but let's talk about first instantaneous velocity. So person is interested in this point t2. So since it is not an average quantity, it's instantaneous at that particular time, that is t1 or t2, what is the velocity? So what you have to do, since you know the relationship between how your distance is changing with respect to time, just you have to find the slope. Slope means the slope, that is dx by dt. If you will find this dx by dt, that will give you the instantaneous velocity at that instant of time. So this slope will give you the velocity at that instant of time, that is dx by dt. You have to differentiate how the object is moving with respect to time. That will give you the instantaneous velocity. Let us now look at one example of the instantaneous velocity. Suppose you have example. Suppose an object is moving with respect to time with this relationship. It can be a relationship. So this is a kind of relationship in this manner. This is my time axis, this is my x-axis. So this is this kind of a relationship. And you wanted to find the velocity at suppose t equal to 2 seconds, t equal to 4 seconds, t equal to 6 seconds. These are the points or instants where you wanted to find your instantaneous velocity. So how you will find? Just you have to do the derivative of x with respect to time. So what will be the derivative? So velocity equal to dx by dt. So what is the derivative? Derivative will be 0.08 t cube. This will be equal to 0.08 3t square. So this will come out to be 0.24 t square. Now we are interested in finding the velocity at time equal to 2 seconds, time equal to 4 seconds, time equal to 6 seconds. So first, time equal to 2 seconds. Just you have to put t equal to 2 seconds here. So it will become 0.24 2 square. So it will come out to be 0.96 meter per second. Similarly, time equal to 4 seconds. So velocity will be 0.24 4 square. This is 3.84 meter per second. Next, time equal to 6 seconds. So velocity will be 0.24 6 square. So this will be 8.64 meter per second. So you will see your velocity at that instant of time come out to be 0.96 meter per second, then 3.84 meter per second, and then at last for the 6 seconds it is 8.64 meter per second. So what are these terms? What are these values? These values are the slope at this instant of time. For 2 seconds, this is the slope at this point, this is the slope at this point, and third one is the slope at this point. So slope of the x versus t graph at any instant of point give you the velocity. Now let us look at another example. If some distance is varying with respect to time in this way, this is the relation. How our distance is changing with respect to time, and the nature of curve will be like this. It is like this nature. Okay? Like this nature. And you wanted to find again your velocity at t equal to 2 seconds, t equal to 4 seconds, t equal to 6 seconds. So what you will do to find the instantaneous velocity? Just derivate it, dx by dt. What will be your dx by dt? So it will be 1 plus t square minus 4 d by dt 1 plus t, and this will come out to be minus 4 plus t whole square. Now you wanted to find the velocity at different point. So what you have to do? At t equal to 2 seconds, what we have to do? Velocity equal to minus 4 1 plus 2 whole square. This is minus 4 3 square. What will be this? This will come out to be 0.444 meter per second, and this is negative. What does this negative sign tell us? Is suppose you have your object and this is some origin O. Let's divide this one, and the object initially at time t equal to 0, our object was at 4 meter. So our object at time equal to t0 was here. Okay, let's take this as the x-axis or x as a distance. So now as the time progresses, the distance is reducing. Means at some time it's coming out to be the distance is coming out to be less than 4. So that's mean our object is moving in the opposite direction of the motion, that is in the negative x direction. Therefore, due to this negative x direction, we have a negative sign here. Means our velocity is in the negative side. In the case if our object is moving in this direction, then we will have a positive velocity. Now let's find other velocities. At time t equal to 4 seconds, v velocity will be equal to -4, 1 plus 4 whole square. What will be this? 0.16 meter per second. Then finally, time equal to 6 seconds, we have a velocity of -4, 1 plus 6 whole square, that is 0.0816 meter per second. And you will notice from here, as we are progressing in time, our velocity magnitude, here will be negative, all this will be negative. So as the time progresses, your velocity is reducing, means the object is trying to come at rest. I hope this is clear to you. Now let us look at another example. So the example say we have a relationship between the distance and time as per this, a plus vt square. Okay, where a is equal to 8.5 meter, v equal to 2.5 meter second square, and t is our time. And what is asked? Find the velocity. We have to find velocity at what point? At t equal to 0 second and t equal to 2 seconds. So it's simple. Now what we have to do? We have to differentiate x with respect to time. If we will differentiate it, it will be 2bt. Now substitute this one. If time equal to 0 and this is equal to velocity, our velocity is also equal to 0, because if we will substitute t equal to 0 here, this term will go away. So our velocity at time t equal to 0 is 0. Now let's consider time equal to 2 seconds. So time equal to 2 seconds, dx by dt, or our velocity is equal to 2b into 2. And what is our v value? V is our 2.5. So what will be this value? So we have at this 2 seconds, we have a 10 meter per second velocity. Okay. Now in this video we have learned how to find the instantaneous velocity at any time. Now let's find the average velocity also for this distance versus time profile. So if someone asks, find the average velocity between t equal to 2 seconds and t equal to 4 seconds for the same question. So how you will do? So since we have learned from our previous video that average velocity is displacement, that is final position minus initial position divided by final time minus initial time, that is the time interval. So this term is known as displacement and this is the time interval. So what is the final position? At final position is t equal to 4 seconds. So we will substitute here a plus 4. So 4 square, that will be 16. that will be 16v minus, what is the second? 2 seconds. Initially is 2 seconds. So this will be a plus 4b divided by, what is the time interval? 2 seconds. So if we will simplify this one, 16b minus a minus 4b divided by 2. So this a will cancel out and we will be left with 12v divided by 2. This is 6b. And what is our b value? That is given in the question, that is 2.5. And the answer will come out to be 15 meter per second. So this value is the average velocity between time equal to 2 seconds to time equal to 4 seconds. Till now we have looked for the instantaneous velocity. Now let us look about instantaneous speed. So let us look now for the instantaneous speed. So instantaneous speed is just like an instantaneous velocity, but just we have to take the magnitude of the velocity, or we can say instantaneous speed is the magnitude of velocity. We have seen our velocity can be negative or positive, but the instantaneous speed is just the positive value, that is the magnitude, positive magnitude of the velocity. If our instantaneous velocity is negative 26 meter per second, then our speed, instantaneous speed will be 26 meter per second only. Why it is so? So since our last video, we have seen that average velocity and average speed are not equal every time, but instantaneous speed is equal to instantaneous velocity with its magnitude. Why it is so? We will see in here. So suppose we have again one relation between x versus time. Suppose this is a kind of relationship and we are interested at this point, suppose t1 time. Now let's concentrate on this point where we wanted to find our instantaneous velocity and instantaneous speed. And if we will zoom with this point little bit, we will see there is a very small difference in x2 and x1 and t1 and t2. Now I will zoom this part further. That will be you have point that is at a time t1 and second point that is at a time interval of t2, at a time of t2. Now if you will connect a line between these 2 points, this will give you the slope, and this slope is between, this is x2 and this is x1. This is a slope. So how we can find the slope? Slope is equal to x2 minus x1, t2 minus t1. And what is x2 minus x1? This is the displacement, and this is t2 minus t1, that is the time interval. So this is basically the velocity, average velocity between t1 and t2. So now if we will see, actually we have this distance. This is our actual distance. If you will see the curve, it is like this, and this is the actual distance. Let's take this one as a s. S is the total distance between x1 and s2. Since our time, that is t2 minus t1, is approximately equal to 0, that is our this time interval is approximately equal to 0. That means these 2 time intervals are very close. At that time, if we will find if we will find your average speed, that is s divided by t2 minus t1, that will be approximately equal to your average velocity. So that's why we say instantaneous velocity, that is when delta t, we can write this one as a delta t also, approaches to 0 at any particular time, that is in this case is the t. So in that case our x2 minus x1 divided by t2 minus t1 is approximately equal to s t2 minus t1. Or we can say our velocity, instantaneous velocity, is equal to instantaneous speed. And this is the reason why our instantaneous velocity is equal to instantaneous speed with a positive magnitude. I hope this is clear to you.